Good morning. Today our topic is, we are continuing our mechanical methods using triaxial testing and direct shear test. Based on these tests, how we are identifying the various ground properties, soil properties which we required for the construction or any other project, what we required as per the project demands. So for these methods, these are some of the web references which we are follow for better understanding these two methods. So coming to these mechanical methods, one more important is this triaxial testing. Coming this triaxial testing is it is a laboratory technique which we are using understanding the various engineering, geotechnical engineering to assess the mechanical properties of soils and based on the rock materials under various stress conditions. Under different stress conditions, this laboratory technique is useful. Coming to in this triaxial testing, we are in a cylindrical soil, our rock sample is subjected to control axial stresses while confined laterally by pressure cell. So this is the one more laboratory test for understanding the engineering properties. In this, this allows engineers to measure the soil response to different stress paths such as compression, consolidation, shearing. So based on these different stress paths, we are understanding how, and this triaxial test allows the engineer which is to measure the soil responses. In this, triaxial testing provides different data for understanding the soil behavior, determining the shear strength parameters, designing foundations, which type of foundations are better for the required construction, required physical infrastructure, and what are the various slopes involving it, that what are the retaining structures are helpful and which type of retaining structure suitable for the based on the designs and based on the soil response for the various stress paths for understanding these using these triaxial testing. This is provides the crucial data which we require for better understanding about the soil properties, as well as for it is further helpful for designing the various which type of design is adaptable for the based on the all these soil response from the various stress paths which is included. So in this, the detailed explanation of the stress path, coming to this, for understanding the behavior of the soil under various loading conditions. Various loading conditions, then only we will get the different stress paths. These different stress paths which we are understanding under including the compression, consolidation and shearing, various loading conditions. So it comes under different loading conditions for understanding the better performance in these. So the first one is we are going to prepare the sample preparation. The sample preparation plays a major role. So in this, the first sample preparation, whenever we are preparing the sample for desired dimensions, based on that sample preparation, we are just typically we are understanding the next stages. So in this sample preparation, the first step which we follow, we are considering a cylinder sample of soil is carefully prepared and trimmed to the desired dimensions. So required dimensions, we are creating one cylindrical sample using the whenever the properties of required that particular location, we are taking from that location and taking from the exact where we require the properties, we are taking from the soil for that location and we are preparing this sample. This sample is typically placed in a cylindrical mold with 4 stones at the top and the bottom to allow for drainage. And next one is the saturation. In this saturation, for cohesive soils, the sample is usually saturated with water to ensure that it behaves as a saturated material during testing. So, saturation is achieved by submerging the sample in water and allowing it to soak until no air bubbles escape. So, this is one of the important steps which we consider in the triaxial testing process. Next, the assembling the triaxial cell. The saturated sample is placed inside the triaxial cell, which consists of a cylindrical chamber with a rubber membrane surrounding the sample. So, the chamber is filled with confining fluid, usually whether it is belongs to water or soil, which applies pressure to the sample laterally. So, in this assembling the triaxial cell, in this we are confined that fluid and which applies the pressure. We are applying the pressure into the to the sample wherever we are considering that soil. So after that, the confining pressure is applied to the sample by pressurizing the fluid in the triaxial cell. So we are increasing and we are applying that required pressure for understanding those soil, how it behaves based on all these different types of stress paths. Not only single, we are applying in different ways. So the stress paths we may choose based on the which type of property is required and how it behaves, and for better understanding the soil absorption conditions and how the soil is going to behave. So for that we are confining this pressure applying to the sample into the triaxial cell, and it helps simulate the stress conditions. So it depends upon it experience in the field. So it depends upon this pressure helps simulate the stress conditions. So and to that soil or rock would experience in the field. In this confining pressure we are this is the one of the step which we follow for understanding the how much application of the pressure is required, what are the various conditions of stress. It depends upon the requirement of the infrastructure. So now axial loading. Now we are applying this axial loading. This axial stress is applied to the sample through a piston which compresses the sample axially. Whenever the axial stress is applied to the sample and it compresses the sample axially, the axial stress can be applied at a constant rate or in increments depending on the testing requirements. The axial stress can be applied at a constant rate. So in this we have to understand this constant rate very carefully. So here in this triaxial test we are applying the stress constantly, the constant rate, and in terms of increments, and it depends upon the test requirements in some, but it is applied in constant rate or the increments also in between the required intervals. So within the some specific intervals, that is also important in this triaxial test. In this measurement during the test, various parameters are going to measured including the axial and radial strains, pore water pressure and axial and radial stresses. These measurements provide the valuable data on the stress strain behavior, shear strength and deformation characteristics of the soil. So based on all the above detailed things what we do, the sample preparation, after that the pressure the applying of the pressure, whenever we are applying the loading, and we are measuring the whatever the various parameters which we are included in these test. So finally all these based on these data we are going to understand that particular sample, soil sample, stress strain behavior, shear strength and the deformation characteristics of the which sample which we consider. We are understanding all these data in this using this triaxial test. In some of the triaxial stress which we are understanding the shearing also. So the sample may be subjected to shearing. Whenever we are applying the axial, we are getting all these conditions, whenever we are applying the shearing, that shearing load by applying additional axial load while maintaining a constant confining pressure, here we are understanding the shear strength parameters of the material. So once the triaxial test is going to completed, whatever the data we are collecting at the time of the test, whenever we are applying the axial load, confining pressure, and various data what we collected from the test, we are going to analyze to determine the material strength, stiffness, and other relevant properties which we require. So in this is information used to assess the stability of the soil slopes, for which type of design is suitable, and the design foundations also it is helpful, and evaluate the performance of earth structures also it is helpful. This triaxial test is widely used for characterizing the mechanical behavior of the soils. So in this, it provides valuable insights into the response of these materials to different loading conditions. The loading conditions gives the various types of the stresses, depends upon the which type of loading, the axial loading, shearing, so different. It depends upon the which type of loading condition, and based on that we are getting the required data analysis and which property is going to enhance for understanding the that particular sample. So in this, helping engineers make at the time of the design for foundations, at the time of the foundation which type, and for at the time of the retaining structures whenever is required. So for that also which type of retaining structures and which type of design is suitable for the soil conditions also, such type of decisions, such type of important decisions which we are going to understand for this using this triaxial testing in for the geotechnical engineering projects. So in this triaxial testing, it allows the assess the main purpose, coming to the whole the whatever the detailed parameters which we understand. In this the test is assessing soil behavior under various stress conditions, including drained and undrained conditions. It provides valuable insights into the soil stability, shear strength, and deformation characteristics. Like this, for understanding the various retaining structures, pavement systems, all these parameters, this is the main purpose for conducting these triaxial test. Coming to some of the applications which we are going to for these triaxial testing, in these for material characterization, for design purpose, and it helps for the understanding the soil response for various loading conditions, is one of the important applications which we use for in this triaxial testing. So this is the one of the important tests which is going to provide, and for understanding the various loading conditions for the shear, based on the shear paths and designs, various design foundations, all these characteristics which we are going to understand these for using this triaxial testing method. So this is the one of the important mechanical method which we understand for improving the ground things, ground improvement techniques. And the next one is, and using this test we are understanding where the lack of the conditions are there, which is going to enhance the particular soil property. So all these parameters we are going to understand using this triaxial testing. The next one is the direct shear test. Direct shear test is also one of the important and fundamental geological laboratory test. It is also for understanding the shear strength of the properties of soils and other granular materials also. It is particularly essential in evaluating the stability of soils, like triaxial test. This is also for design foundations and retaining structures also. In this, the detailed test procedure for direct shear test is also in this. The first one is the sample preparation. So here also the cylindrical or square shaped sample is prepared with specific dimensions and placed with the shear box apparatus. So it is whether it is cylindrical or square shaped soil sample which is prepared for the desired dimensions or required dimensions or available dimensions and placed within the shear box apparatus. The sample is typically compacted to a desired density or moisture content depending on the testing objects and soil characteristics. So the sample is typically compacted to the density, moisture content depending on the testing objects and soil characteristics. So in this, the setup, the soil sample is enclosed with a shear box which consists of two havels, the upper and the lower parts. In this, upper part is connected to a loading system, the lower part remains fixed. In this, the two in this shear box, the upper one is, it is connected to the loading system and the lower parameter is fixed one. The interface between these two havels of shear box is where the shear plane will form during the test. So in this setup, the consolidation, before applying the shear stress, the soil sample may undergo a consolidation phase to remove any excess of pore water pressure. So at the time in direct shear test, there is no, it is not allowed to get for better understanding and getting the better characteristic, better properties for understanding. In these direct shear test, we are not going to allow the excess of the pore water. So the pore water pressure we are going to remove using this consolidation step. In this consolidation, we are applying before applying the shear stress. In this sample, we are going to go into this consolidation phase for removing this excess pore water pressure. In this, we are going to achieve, using this consolidation, we are achieving by applying, how we achieve, that is in this vertical stress to the sample while allowing time for water to dissipate and soil particles rearrange. So in this, consolidation is achieved by applying this vertical stress to the sample while allowing time for water to dissipate and soil particles to rearrange. Now moving to this shearing. After once consolidation is completed, we are going to the next one, that is the shearing. In this, shear stress is applied horizontally to the upper half of the shear box at a constant rate or incrementally. The shear stress causes the soil particles along the predetermined shear plane to move relate to each other. So in this, the soil particles along the predetermined shear plane to move relative to each other. The shear displacements or deformation is measured through the direct shear test, using the direct shear test. So now we are going to collect the data during the shear, the applied shear stress and corresponding horizontal displacement, or whether it is strain, are continuously monitored. So whenever we are monitoring these two parameters, this shear stress and the strain, so the relationship between these shear stress and shear displacement is recorded to generate a shear stress displacement curve. So using these, the variations between these two, we are closely and continuously the monitor is required. So based on that monitoring, we are getting all these data collection what we have. Now moving to the analysis, the test results are analyzed to determine the peak shear stress, which represents the maximum resistance to shear deformation exhibited by the soil. So in this, we are going to analysis, we are considering this analysis portion. Here we are understanding where we are going to determine that particular parameters are included in this analysis. Those are, for these, the direct shear test is the peak shear strength, which represents the maximum resistance to the shear deformation exhibited by the soil. So other parameters such as angle of internal friction and cohesion, if applicable, it is applicable, for some of the soil conditions only. In some of the it's not applicable. Soils may cohesive soils or non-cohesive. So it depends upon the when it is applicable. Can be calculated from shear stress displacement curve, which is closely monitored from the data collection. Continuously that monitoring is going to done. So in these, the interpretation engineers use these test results to assess stability and behavior of the soil in various geotechnical applications. The shear strength parameters obtained from the direct shear strength are crucial inputs for soil stability analysis, foundation design and other various geotechnical engineering projects. So this whole summary, the direct shear test provides valuable insights into the shear strength characteristics of soil, aiding engineers in making informed decisions regarding the design and construction of the structure. So in this, the purpose in this, the whole detail after completion of the detailed explanation, the direct shear stress soil sample is placed between two parallel plates and subjected to a horizontal shear force. The force required to cause shear displacement is measured and shear strength parameters like cohesion and angle of interfriction are calculated. In this purpose, the direct shear testing is used to assess the shear strength properties of soil, particularly cohesive soils and rock joints. It helps engineers evaluate soil stability and the performance of geotechnical structure under shear loading. So these are the things which we are going to understand in these mechanical methods. These two previously already we understand the cone penetration test, standard penetration test like this. These are the some more mechanical methods. All these mechanical methods are helpful for understanding the whenever the required soil is there and where we are going to construct and how we are understanding the geological properties based on the shear stress and which type of mechanical method gives the what kind of parameters, what kind of properties, soil properties we are going to understand and what are the various applications. All these parameters we are understanding in these mechanical methods. And after understanding the geological properties, we are going to conclude required any enhancement or any replacement or which type is the best for the based on the remaining parameters, based on the remaining conditions we are understanding and we are suggest and we are going for proceeding the further steps. So it helps, all these mechanical methods are helpful for better understanding the soil parameters for getting the better physical infrastructures or constructions. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.